Welcome to my presentation. In this presentation, let us try to solve system of linear equations using Gaussian elimination method. Let us take a simple example. And in this example, if we want to solve for the variables x and y, and if the given equations are as follows: 2x minus y is equal to 0, and then minus x plus 2y is equal to 3. Let's say this is equation number 1, this is equation number 2. We will use the Gaussian elimination method to solve this problem. So step number 1, let us identify the augmented matrix for this particular this particular set of equations. So the augmented matrix we can write by picking up the coefficients of x and y from equations 1 and 2 and then writing them out. The coefficient of x is 2, coefficient of y is -1, and the constant number is 0. In the second equation, the coefficient of x is -1, the coefficient of y is +2, and the constant number is 3. So this is our augmented matrix. Okay, so we want to find the values of x and y, and to do that we're going to use the Gaussian elimination method, as we mentioned. We want to transform this augmented matrix to this type. I'm going to write that in this different color. That way we know that is what we want to achieve. We want ones along the major diagonal and then zeros below the major diagonal, like that. So we want ones along the major diagonal, we want zeros below the diagonal, and then whatever numbers come, those will be based off the row operations which we're going to perform. So let's get started. So therefore in here we want 1 in this location. So we want a 1 in this location, and to achieve that we're going to do the following operations. We're going to say the new R1 we can write as R1 plus R2. If we do that, we should be able to get 1 there. So how do we do that? 2 minus 1 is equal to 1, -1 plus 2, that is going to be equal to 1, and then 0 plus 3, that is going to be equal to 3. That is the first row. The second row is -1, 2, and 3. Now let us write this in a clean manner. So this is what we have: 1, 1, 3, -1, 2, and 3, like that. So if we were to look at this, we will always come back and then draw this major diagonal and then see where we are on the finish line. We wanted a 1 in the first row, first column. We've achieved that. Now as a second step, we want to get a 0 in that location, and to arrive at that, we'll do the following things. So we'll write down, we'll do the row operation in here, and to get that, we'll write the first row as is. The new R2, let me get some more space here. The new R2 is going to be equal to R1 plus R2. If we combine R1 and R2, we should be able to get that. So the first row, we'll come back and then fill it up in just a minute. But in the second row, if we were to add 1 to -1, that becomes 0. Then we go to do for all the elements in that second row, and then we have 1 plus 2, which is going to be equal to 3, and then 3 plus 3, which is going to be equal to 6. That is in the second row. In the first row, we have 1, 1, and 3 here. So therefore, if we were to, since we did all the math in here, we'll write it out in a clean manner in this next place here: 1, 1, 3, and then we have 0, 3 and 6 like that, and then we'll draw a line there, and then when we draw the line along the major diagonal, we see now that we have a 0, we have zeros below the major diagonal, we have ones in second row, second column. We want a 1 in this location, and therefore to achieve that we're going to perform row operations to be able to arrive at that. So the new R2, if I were to come back in here, let me just take this one out, I'll come back and then draw that in a minute. The new R2 is going to be equal to existing R2 divided by 3. If I take row 2 and then divide it by 3, then I should be able to get 1 in that location. So therefore 0 divided by 3 will be 0, 3 divided by 3, that will be equal to 1, and then 6 divided by 3, that will be equal to 2. That is the second row. The first row will come down as is, 1, 1 and 3. So if I were to write this in a clean manner, I have 1, 1, 3 and then 0, 1 and 2 like that. So as you can see, we have achieved what we wanted. We wanted ones along the major diagonal, we wanted zeros below the diagonal, and then now we are ready to read the answer from this final augmented matrix. From here we can, if we want to see it in terms of a system of linear equations, we can write that too. Since this is x, and since the values in this in the left hand side are coefficients of x and y, let me just write x and y on top there. So that is going to be 1x plus 1y is equal to 3, and the second equation we have y is equal to 2. So we have the answer right here for y, which is equal to 2. That is one answer. And if we were to go back and then back substitute into the first equation what we have, we should be able to get the value of x. So therefore x plus y is equal to 3, x plus 2 is equal to 3, therefore the value of x is equal to 3 minus 2, which is equal to 1. Therefore the value of x is equal to 1. The solution what we have here is x equals to 1 and y is equal to 2. So we were able to solve this system of linear equations using the Gaussian elimination and then Gaussian elimination method, and then we've used the back substitution to be able to find the values of the other variable. So we got the values of x and y. In my next presentation, we will try to solve the same example problem using other advanced methods.